Hi, this is a quick lesson on solving inequalities. When you're solving inequalities, you're dealing with, instead of equations that have equal signs in it, you're going to be dealing with equations that have greater than or less than symbol in it, or possibly a greater than or equal to, or a less than or equal to symbol in it. And then, therefore, your solution is going to have one of those symbols as well. We've talked before about, those different symbols and how we rank numbers on the number line, but we are going to just have a quick little drill on matching descriptions to inequalities here. This first one, x is less than 48. Now remember, it's going to point to the smaller one, or it's going to act like it wants to eat, Pac-Man, eat the larger one. So we need to kind of match this with which expression matches that. So x is less than 48 miles per hour. If this was a word problem, that solution would match that. The next one, 21 is less than x is less than or equal to 48. So here you're looking at a solution set that is between two amounts here. So it's greater than 21 but less than 48. And so that would match up with a possible word problem that would maybe end up with more than 21 candies but no more than 48. So that matches down here. The next one we have m is less than or equal to 48, and that's going to make sense with at most 48 hours. So our solution set would be up to but no more than 48 hours. So that kind of matches there. P is greater than 21, greater than or equal to 21. That's going to match up with the very first one, that if we had, looking at votes, have at least 21 votes, the minimum is 21. So our solution set would be greater than or equal to 21. And a solution set that would end up being 21 less than m is going to be, that our solution is greater than 21. We can kind of turn that around. So we have more than 21. So you can see there's going to be a couple different ways that you could write this. This solution set greater than or equal to 21 for at least 21 votes, that could be written backwards. It's still pointing at the 21, that 21 is less than or equal to your solution set. Or the at most 48 hours, that could be written as 48 is greater than or equal to m, that you could turn that around. More than 21 students, generally you could rewrite that as m is greater than 21. Less than 48 students, or 48 miles per hour, that could be written as 48 is greater than x. I'm just kind of switching that around here. For the most part, I think it's easier to visualize your solution set when you have your variable first, like this, or this, or this. I think that's, and this one as well. That's going to be a little easier to visualize your solution set, and when we start working some of our problems, I'll graph that so you can see that. Now this one here where you have, limits on either end, a lower limit and an upper limit, generally you're not going to turn that around and say your variable and go from greatest to least. This goes from least to greatest. This would be most accurate. You're going to see that more often. Okay, that probably feels a little out there, but I think once we start solving some of our inequality statements, the solution set will make a little more sense. Okay, so basically you're going to be using the same skills to solve these inequalities that we've been using to solve our single variable equations. So one of the things that I really want to point out is when you get working with this is you need to be careful that when you are dealing with inequality where you multiply or divide both sides of the equation by a negative number, anytime you're dealing with multiplying or dividing with a negative number, your inequality is going to change. So we'll take a look at how that happens. But first I want to solve a couple simple problems where we're going to be dealing with, for the first two, we're just going to be dealing with the additive inverse, and we're not going to see any change in direction on our inequality. But I really want to focus on mapping and kind of getting an idea of visualizing your solution set. So this first one, x plus 3 is greater than 5. We're going to go ahead and deal with our additive inverse just like we would if this was an equal sign in here. So you zero in on which side is my variable on. It's on the left side. What's attached to it? We have 3 added to it. We undo that by subtracting 3. So we're going to write our computation line, bring everything down. This eliminates, so we have variable by itself. X is still going to be greater than the right side. 5 minus 3 gives us 2. So our unknown, our solution set, is greater than 2. Now what would that look like on a number line? On your number line, I'd like you to, I think it just makes sense that you need to visualize where your number is in relation to 0. So I'm going to put 0 and I'm going to put 2 on here. That's the minimum I think you need to have on your solution set to help you visualize this a little bit. So you're going to be looking at a solution. All the numbers that are greater than 2 are going to be over here. I'm going to put a circle around 2. I'm not going to bubble that in because it doesn't include 2. 2 is just my limit. Up to, but not including 2, coming from the greater side. So all of our solution, all of the numbers on our number line that are greater than 2 are over here. So it means our solution set that makes a true statement here are the digits that are over here on the right side of 2. So we could plug in 5 here. 5 plus 3 is 8, and yep, that's greater than 5. That makes a true statement here. But if I plugged in 1, which is on the left side of 2, on the smaller side of 2 here, if I plug in 1, 1 plus 3 is 4, and that is not greater than 5. So we can see that our solution set makes sense when we shade to the right of our limit here. Okay, so we're going to continue on using the same concepts, the additive inverse. I've got x minus 1 is less than or equal to 2. And so I'm zeroing in my variables on the left side. I've got 1 subtracted from it. The opposite of that would be adding 1. If I add 1 to the left side, I'm going to add 1 to the right side. So I'm using that very same logic that we used with single variable equations. This eliminates here. I've got x is less than or equal to 3. So again, the minimum I'd want to think about on my number line would be where is 0 and where is 3 on my 3 in relation to 0 on the number line, and then start circling. I'm going to identify that 3 is here, and I'm going to bubble in the 3 here because that's going to imply that 3 is part of my solution set. Okay, and so my solutions are going to be less than 3, less than or equal to 3, so that would be this direction. So when I shade this direction here, so I could plug in 1 here. 1 is in that solution set. When I plug in 1 minus 1 is 0, and yep, 0 is less than or equal to 2. But if I would plug in 4 on the right side of 3, 4 minus 1 is 3. 3 is not less than or equal to 2. So you can see that this is not part of our solution set. So I think what you're going to see is that it's going to be easier for you to visualize your solution set when you have your variable first. So you can visualize, where that is in relation to your limit here. So that's what I was getting at up here, that I think it's easier for us to make sense when our variable, we write our inequality with our variable first. Okay, so this next problem we're going to be looking at, again, it's just going to be one step, but this time we see that the relationship is multiplication here. And so you're thinking about how do we undo multiplication? We're going to go ahead and divide each side by that coefficient. I'm not being very detailed in my description here just because we've done this so many times. So I divided each side by 8. I end up x is less than 8. So my number line, I just want to put the minimum, the 0, and the 8 here in relation to that. 8 is over here. I'm going to circle the 8, but I'm not going to bubble it in because it's not included. It's just the limit. And then all the numbers that are less than 8 are over here. So I could continue with the same logic as far as plugging in, but I'm going to keep this video moving. Okay, over here, we're going to be taking a look at a couple more complicated problems. I have negative 4 times x is less than or equal to 24. So I'm going to be, actually what I want to do is I'm going to go ahead and rewrite this so you can see what happens. So when I want to get my variable by itself, that's multiplication there, I undo that multiplication with division. So I'm going to go ahead and divide each side by negative 4. That eliminates. I've got the variable by itself. But you see how, I'm just going to bring down my number, that 24 divided by negative 4, the right side of my equation now becomes negative. Whereas here originally, the left side was negative, the right side was positive. Now I've got my left side positive and my right side negative. That really kind of makes sense that I'm going to change the direction of my inequality. So whenever you're dividing or multiplying by a negative number, you need to change the direction of your inequality in your solution. So this would be x is greater than or equal to negative 6. So if I was drawing my number line, I'd want to draw 0, and I'd want to draw negative 6, where negative 6 is in relation to 0. And I'm looking at all the numbers that are greater than or equal to -6, means I'm going to circle and bubble in the -6 and then shade to the right. All those solutions that are greater than -6 are over here to the right. Okay, and the next one, I've got 2 steps here. Again, I'm looking at the left side of my equation because that's where my variable is. I want to start with the constant first. I need to deal with that first. So I need to think of my additive inverse. I'm going to be, the additive inverse of 7 is -7, so I'm going to subtract 7 from each side. That eliminates this, so I end up with -4x is less than, and this actually comes out to be 1. Now I haven't changed any signs yet because I haven't multiplied or divided or anything by a negative number, but I'm about to do that. So I need to get this variable by itself. This is connected by multiplication. I undo that with division. I'm dividing by a negative number, so that's going to be a heads up that I need to change the direction on my solution. So I've got x by itself, but I'm going to change the direction of this, and so this would be x is greater than -1/4. Again, just to keep this moving, I'm not going to graph that. Okay, looking at this next one, I've got a variable on both sides. I have a constant on both sides. So I'm going to move my variable to one side or the other. So I'm going to go ahead and subtract 4x from each side. Again, subtracting negative numbers, you don't change anything with that inequality. That goes away. So I end up with x plus 1 is less than -2. I'm going to subtract 1 from each side. That goes away. So I have x is less than -3. So there wasn't really anything new there. We could graph each of those, but I think you'd see that it's just like the others. Okay, doke.